This is the project laid for power quality improvement using dynamic voltage restorer. So in this project we have taken three-phase system. For three-phase as a secondary, in three-phase system we use three-phase grid as a source, and linear load and non-linear loads we have done at load side. And for the primary side we have used that voltage source inverter uh, with DC source. So this is the DVR which is used to smoothen that voltage distortion due to the harmonic. And this is the secondary filter, and this is the primary filter. So this is primary, secondary side, this is primary side, and this is the non-linear load which we have used from that three-phase load side. That harmonic is injected through this non-linear load. So for compensating that voltage distortion, we use that voltage source inverter along with the voltage control and with DQ transformation. So this is the control part is used to control that voltage source inverter. And this is the source bus and load bus. So both bus voltages are injected into that control part to provide that gate signal to the inverter. So this is this DC source interconnected with voltage source inverter. The DC source is 700 volt. And then the voltage source inverter is IGBT based 3-leg 6-switch configuration, and that output of the inverter is connected with primary winding, and this is the part used to control that voltage distortion. So to that controlling part we can check through that output of that system. So this is the scope block. So here first we're going to see about that grid side voltage and current representation. So this is the voltage and this is the current. So this is called voltage sag and this is voltage swell. So the voltage sag and swell is compensated by this primary side. This primary primary side inverter, which is along with the DVR, is used to compensate that voltage sag and swell. So this is grid voltage and compensated voltage. So this is the load side. The same thing we can see here, voltage sag and swell. And this is voltage mitigation block. Here we can check that grid voltage, load voltage and injected voltage. This is the series that active filter from load and from source. We can see that reference that compensating waveforms here. And this is the DC voltage which we have applied to the inverter. So these are the output representation of power quality improvement by using DVR.